A star vanishes without a trace. The cosmos is not a serene painting, but a chaotic theater of the strange and wonderful, and astronomers hold the front row seats. Today, we journey through 25 of the most bizarre cosmic events ever witnessed, from silent radio screams to galaxies that should not exist. By the end, you will see the universe not as a static backdrop, but as a living, breathing enigma of impossible scale. We will confront a force dragging our entire galaxy toward an unseen horror and decode a signal so perfect it was labeled a message. What single cosmic mystery has most reshaped your idea of reality? Our journey begins with a force so immense it is pulling our entire galaxy toward an unseen destination. Astronomers call it the Great Attractor, and its existence was not found by sight, but by motion. In the late 1970s, as scientists mapped the grand flow of galaxies across the universe, they noticed something profoundly strange. Our Milky Way, along with our entire local group of galaxies and thousands of others, are all rushing in the same direction at over 1 million miles per hour. It is as if every star system in our corner of the cosmos is caught in a vast, invisible river, flowing toward a specific point in the constellation Centaurus. This is not the general expansion of the universe. This is a targeted local pull, a gravitational anomaly of staggering power. The source of this pull lies hidden behind the dense, dusty heart of our own galaxy, in a region astronomers poetically call the zone of avoidance. From our vantage point on Earth, the central plane of the Milky Way is like a towering wall of cosmic fog, blotting out the light from anything behind it. We cannot see the Great Attractor directly with optical telescopes. We had to infer its presence by watching how other galaxies move, like feeling a strong wind by watching leaves swirl. Their peculiar trajectories pointed to a gravitational anchor of unbelievable mass. So what is it? The leading theory suggests it is not a single, monstrous object, but an immense concentration of mass known as the Norma cluster, a supercluster of thousands of galaxies bound together. But even that may not be enough. Some calculations hint that the mass required to create such a powerful pull might be far greater, pointing to an even larger, unseen structure laced with dark matter. It could be a junction in the cosmic web, a knot where the filaments of the universe converge, creating a gravitational well so deep it tugs on everything for hundreds of millions of light years. The true nature of the Great Attractor remains veiled, a reminder that the most powerful forces shaping our cosmic journey are often the ones we cannot see. It is a humbling thought. We are not merely drifting in an expanding universe, we are being drawn with irresistible force toward a mystery hidden in plain sight, just behind the glittering curtain of our own galactic home. This gravitational pull toward the unseen is a cosmic theme, a universe that hides its most profound secrets, but sometimes the mystery is not in what we cannot see, but in what we watch a star do right before our eyes. In the constellation Cygnus, over 1,000 light-years away, a seemingly ordinary star named KSE 8462852, now better known as Tabby's star, began to behave in a way that defied every textbook. The Kepler Space Telescope, designed to hunt for planets by spotting the tiny, regular dips in starlight caused by their orbits, found something utterly different here. This star did not dim by a neat, predictable 0.01%. It plunged into darkness. The telescope recorded sudden, chaotic drops in brightness of up to 22%, as if something colossal and jagged was drifting across its face. A single planet, even a gas giant, could never block that much light. This was not a planet transit. This was an astronomical anomaly of the highest order. The data painted a bizarre picture. The dimming events were deeply irregular, with no set pattern or timetable. They varied wildly in depth and duration, sometimes lasting for days, other times for mere hours. It was as if the star was being sporadically shrouded by a vast, uneven swarm of objects. The most famous natural explanation points to a gigantic family of comets, perhaps thousands or even millions of them, breaking apart in a catastrophic collision and creating a thick, dusty cloud that orbits the star in a clumpy, irregular ring. Another theory suggests intrinsic stellar activity, where the star itself is variable in a way we do not fully understand, perhaps surrounded by a clumpy disk of its own ejected material. Yet the sheer extremity of the dimming forced scientists to confront a more speculative, thrilling idea. Could this be evidence of a Dyson swarm? This is a hypothetical megastructure, a concept from science fiction given mathematical form by physicist Freeman Dyson. The idea is that a sufficiently advanced civilization, having exhausted the energy of its home planet, might construct a vast array of solar collectors in orbit around its star to harness its total power output. Such a structure would be incomplete and uneven, blocking starlight in strange, non-repeating patterns, just like the data from Tabby's star. While astronomers overwhelmingly favor a natural explanation, the star's behavior was so unusual that they could not immediately rule out an artificial cause. This candid admission of uncertainty is what catapulted Tabby's star into the public imagination. Perhaps the most beautiful part of this story is how it was found. The star was not discovered by a lone astronomer in a dome, but by an army of volunteers. The Kepler mission generated so much data that scientists enlisted the public through the Planet Hunters website. Ordinary people, from teachers to taxi drivers, sifted through the light curves of 150,000 stars, flagging anything that looked odd. It was these citizen scientists who first tagged the star's bizarre light pattern, bringing it to the attention of professional astronomers, including Tabitha Boyajian, for whom the star is now nicknamed. This makes Tabby's star a dual symbol, a cosmic puzzle that challenges our understanding of stellar behavior while also representing a new era of collective discovery, where anyone with an internet connection can help solve the universe's greatest mysteries. The star continues to be watched, its secrets still guarded, a reminder that sometimes the most compelling questions come not from the void, but from a flicker in the data. The flickering of a distant star is one kind of mystery, but the universe has another way of announcing its secrets with a sudden, deafening shout across the radio spectrum. These are fast radio bursts, or FRB. For a single millisecond, less time than it takes to blink, a source somewhere in the deep cosmos unleashes a radio wave blast with more energy than our sun puts out in 80 years. Then it vanishes. The first was discovered in 2007, buried in archived data from the Parkes Radio Telescope in Australia. It was so bright and so brief that for years, astronomers debated whether it was a genuine cosmic signal or some local interference, a glitch from a microwave oven on the observatory grounds. But then more were found, and the reality became undeniable. The universe is filled with these brilliant, ephemeral flashes, each one a colossal explosion of radio energy from billions of light years away. The central challenge is their brevity. By the time a telescope swings to look, the burst is already ancient history, leaving behind only a ghostly imprint in the data. Pinpointing their origin galaxies, let alone their specific sources, seemed almost impossible, that is, until astronomers found the repeaters. The most famous is FRB 121102, the first repeating fast radio burst ever identified. This source, located in a dwarf galaxy 3 billion light-years away, does not fire just once. It erupts again and again, in unpredictable fits and starts, allowing telescopes to stare at its location and finally trace the bursts back to their home. This repetition ruled out any cataclysmic, one-time event like a star being torn apart by a black hole. The source had to be something that could survive its own outburst, something that could reload and fire over and over. Then came an even more startling discovery, FRB 202000120e. This burst did not come from a distant, alien galaxy. It originated from within our own cosmic backyard, inside the Milky Way, and its location was perhaps the most surprising of all, a globular cluster. Globular clusters are ancient, dense balls of stars, some of the oldest structures in a galaxy. They were thought to be quiet retirement homes for old stars, not the kind of place you would find the engines for the most energetic explosions in the universe. This single detection forced a dramatic rethink, suggesting that whatever creates some FRBs can form in environments devoid of young, massive stars. The leading theory now points to magnetars, which are neutron stars with magnetic fields so intense they could strip the information from a credit card from halfway across the solar system. A starquake on the surface of such a magnetar, a sudden cracking of its rigid crust, could theoretically release a titanic pulse of radio waves. The galactic FRB seemed to confirm this, as it was traced to a region known to host a magnetar. But the extreme bursts from billions of light years away, the ones that have traveled across most of cosmic history, demand an even more powerful engine. Could they be from magnetars born in unusual ways, or from collisions between ultra-dense objects like neutron stars and black holes? Some researchers still entertain more exotic origins, like cosmic strings, hypothetical defects in the fabric of spacetime, or even the possibility, however slim, of engineered signals from advanced civilizations. The sheer power of these millisecond screams is what captivates the imagination. In a fleeting instant, a source smaller than a city focuses and releases more energy than all the stars in our galaxy combined. They are the universe's most powerful and most cryptic transients, reminding us that even in the silent, dark voids between galaxies, there are voices shouting in a language of pure energy we are only just beginning to hear. A signal that perfect could only be a message. On August 15, 1977, the Big Ear radio telescope at Ohio State University was performing its routine, silent vigil, scanning the sky for narrowband radio signals that might betray the presence of other civilizations. The data printed out line by line on simple computer paper, a string of letters and numbers representing signal intensity. For 72 glorious seconds, the telescope's gaze passed over a patch of sky in the constellation Sagittarius, and the printout erupted. The signal was over 30 times stronger than the background cosmic noise, a pure, unwavering tone at exactly 1,420 megahertz. This was no cosmic static or earthly interference. It was a perfect, narrowband beacon, the exact type of signal scientists had predicted an intelligent civilization might use to announce its presence. The frequency itself was a masterstroke. 1,420 megahertz is the resonant frequency of neutral hydrogen, the most abundant element in the universe. It is the channel on which the cosmos naturally sings, a logical, universal choice for a civilization wanting to be heard above the cosmic din. When astronomer Jerry Amon reviewed the data printout days later, he was so stunned by its clarity and significance that he circled the alphanumeric sequence representing the signal's peak, and in the margin, he simply wrote, "Wow." That single word of astonished annotation gave the signal its immortal name. The WOW signal was everything researchers had hoped for, and it has never been detected again. Despite numerous, dedicated follow-up campaigns, listening to that same spot in the sky for hundreds of hours over decades, the silence has been absolute. It was a cosmic shout that lasted just over a minute and then vanished forever. The hunt for a natural explanation has been just as persistent. One prominent theory suggested it could have been caused by hydrogen clouds surrounding a comet, but detailed analysis showed no known comets were in that precise region of sky at that exact time. Other ideas, like a chance amplification of a weak signal by interstellar plasma, seem statistically desperate. The signal's properties align almost perfectly with what theorists predicted for an artificial beacon, a signal engineered to stand out. Its narrow bandwidth meant it carried very little natural information, just a steady tone, like a cosmic lighthouse saying, "I am here." Its intensity followed the exact pattern expected as the Big Ear's fixed telescope scanned it with its twin beams, rising and falling in a perfect curve, confirming it was a genuine celestial source. For 72 seconds, the universe seemed to speak directly to us, and then it chose never to speak again. That singular, unrepeatable nature is what cements its legendary status. It is the one signal that even the most skeptical scientists cannot easily dismiss. While no one claims it is definitive proof, the WOW signal remains the best candidate, the purest mystery, in our long search for cosmic company. It is a haunting echo from the void, a reminder that the universe might have whispered our name once, and we may spend centuries wondering if we were truly alone in hearing it. That momentary signal was a shout in the void, but the cosmos also holds a profound and unsettling silence. In the northern constellation of Boötes, there lies not a star, not a galaxy, but an immense, chilling nothingness. Astronomers call it the Boötes void, and it is one of the largest known structures in the entire universe, a spherical region of space roughly 330 million light-years across. To grasp that scale, consider our own Milky Way galaxy, a majestic spiral of hundreds of billions of stars. It is about 100,000 light-years wide. Now imagine flying through space for millions of years, past galaxy after galaxy, and then entering a realm where you could travel for another 330 million years at the speed of light and see almost nothing at all. In a universe teeming with galaxies, gathered into great walls and filaments like a vast cosmic web, the Boötes void is a staggering desert, a hole in the fabric of reality itself. When it was first identified in the 1980s, it shattered expectations. Based on our understanding of the universe's large-scale structure, a region this size should contain around 10,000 galaxies. Instead, surveys have found only about 60, scattered like lonely islands in an ocean of darkness. This is not just a little emptier than average, it is a vacuum of terrifying proportions. Its very existence forced cosmologists to reconsider their models. How could the Big Bang, which seeded the universe with a nearly uniform distribution of matter, lead to such an extreme irregularity? The leading natural explanation involves the merging of smaller voids. Think of soap bubbles in a sink. As the water drains, smaller bubbles merge to form larger ones. In the cosmic web, gravity pulls matter into the dense filaments and clusters, leaving behind ever-growing empty spaces. The Boötes void could be the ultimate result of this process, a supervoid created by the merger of countless smaller voids over billions of years. Yet its sheer scale pushes this idea to the limit. Some theorists have proposed even more mind-bending possibilities. Could the void be the imprint of a collision with another universe? In some models of the multiverse, our universe is one bubble among many in a frothing cosmic foam. If, during its early expansion, our universe brushed against another, that contact could have pushed matter away from the point of collision, leaving behind a vast, empty scar. While this remains highly speculative, it speaks to the profound challenge the void presents. It is a cosmic anomaly so vast it invites us to question the very nature of our reality. To look into the Boötes void is to peer into a profound absence, a reminder that the universe is not just defined by the glittering lights we see, but by the immense, silent spaces in between, spaces so large and empty they challenge our fundamental story of how everything came to be. Silence and emptiness define one cosmic mystery, while another presents a vision of impossible geometry. In the constellation Monoceros, over 2,000 light-years from Earth, a dying star has painted a masterpiece against the black canvas of space. Astronomers call it the Red Rectangle Nebula, and its name is a stunning understatement. Seen through powerful telescopes, it does not appear as a messy cloud or a simple sphere. Instead, it glows with a deep, crimson light, structured into a near-perfect X shape, with a series of concentric rungs making it look like a celestial ladder or a vast, glowing hourglass viewed from the side. This is not an artist's rendering, it is a real astrophysical object, and its razor-sharp symmetry is so precise it feels engineered, as if we have stumbled upon a cosmic monument. The vibrant red color comes from a specific type of molecule, long chains of carbon and hydrogen known as polycyclic aromatic hydrocarbons. These complex organic compounds fluoresce, lighting up when bathed in the intense ultraviolet radiation from the central star. They are the same type of molecules found in soot from a candle flame or in the vast clouds between stars, and here, in the red rectangle, they exist in astonishing abundance. But how does a dying star create such a perfect shape? The secret lies in a dance of two stars, a binary system at the nebula's heart. The primary star is a post-asymptotic giant branch star, a sun-like star in its final throes, shedding its outer layers into space. Its companion star orbits closely, and together, their gravitational interaction funnels the ejected gas and dust into two opposing cones, like twin tornadoes spinning off into the cosmos. From our vantage point on Earth, we look directly down the barrel of this double cone system, seeing the edges of the cones as the vivid X shape. The concentric rungs are thought to be periodic ejections, pulses of material expelled from the star system every few hundred years, creating a stacked effect, like ripples frozen in time. So while the structure appears impossibly artificial, it is the product of precise, natural astrophysics, a stellar sculpture carved by gravity and stellar winds. Yet the true wonder of the red rectangle is not just its form, but its function. This beautiful nebula is a prolific cosmic factory. Within those glowing red clouds of hydrocarbon dust, under the harsh ultraviolet light, complex chemical reactions are taking place. Scientists believe environments like this are where the basic building blocks of life, the organic molecules that eventually form on planets, are forged and scattered into the galaxy. The nebula's breathtaking beauty masks a violent, transformative process, a star's death throes seeding the future with the ingredients for life. It stands as a profound symbol, a reminder that the universe is capable of both devastating chaos and exquisite order, and sometimes within that chaos, it creates the very seeds from which new possibilities can grow. From the organic chemistry of a dying star, we turn to a galaxy that seems sculpted by a cosmic artist's steady hand. Hoag's object is a galaxy so perfectly formed it looks like a celestial bullseye floating in splendid isolation against the dark. At its heart is a brilliant, compact sphere of golden yellow stars, ancient suns that glow with a warm, steady light. Surrounding this core is a pristine, delicate ring of vibrant blue, a band of younger, hotter stars burning with fierce intensity. And between these two stunning structures lies a profound and seemingly empty gap, a dark lane of space that cleanly separates the ring from the core. It is a site of serene, geometric perfection, utterly unlike the messy, spiral-armed whirlpools or featureless elliptical blobs that make up most galaxies. This is not a painting or a simulation, it is a real island universe discovered by astronomer Arthur Hoag in 1950, and it presents a beautiful, silent puzzle. How does such a flawless ring form? Our usual story for ring galaxies involves a violent, head-on collision. Imagine a small galaxy piercing the heart of a larger spiral disk like a stone thrown through water. The gravitational shockwave would push stars and gas outward in a rippling ring. But Hoag's object shows no signs of such a traumatic past. There is no disturbed core, no remnant of a galactic intruder, no tidal streams of stolen stars. It floats alone, with no nearby galaxies that could have caused such an impact. This serene isolation rules out the collision theory, forcing astronomers to consider rarer, more subtle processes. One compelling idea involves a phenomenon called resonance. Over billions of years, the natural orbital rhythms within a rotating disk of stars and gas can, under the right conditions, amplify certain patterns. A gravitational instability could have gathered nearly all the galaxy's gas into two distinct waves, one that collapsed inward to form the dense central ball of old stars, and another that was driven outward, where it eventually fragmented and sparked the birth of the brilliant blue ring. The dark gap between them is simply where the resonance cleared out the material, a cosmic no-stars land. Another theory suggests it could be the remnant of an ancient, unstable accretion disk from the galaxy's very formation, a structure that somehow froze in this peculiar, divided state. Whatever the cause, Hoag's object stands as a monument to quiet, internal evolution in a universe dominated by violent mergers. It is a galaxy that chose order over chaos, creating a work of art not through collision, but through a slow, cosmic dance of gravity and time. In a cosmos filled with frantic interactions, its solitary, perfect form is perhaps the most bizarre statement of all, a declaration that profound beauty can also emerge from profound stillness. The serene perfection of Hoag's object speaks of cosmic order, but the universe is also a stage for intimate and violent dramas. In the constellation Sagittarius, a cosmic predator is slowly consuming its partner. This is the Black Widow pulsar, a system named for the spider that famously devours its mate, and it is a morbidly perfect analogy. Here, a pulsar, the super-dense, city-sized corpse of a massive star, spins over 600 times every single second. With each rotation, it sweeps a lighthouse beam of radiation across space, and it is this very beam that is methodically destroying the small, ordinary star locked in a gravitational embrace with it. The two stars are so close that they complete an entire orbit in just over 9 hours, a frantic, deadly dance. The pulsar's power is unimaginable. Its intense magnetic field and relentless wind of high-energy particles blast the facing hemisphere of its companion star. This isn't just heating the star, it is a process of ablation, a stellar sandblasting on a cosmic scale, stripping material directly from the star's atmosphere and blowing it out into space. Astronomers can actually see this happening. The companion star is visibly distorted, stretched into a teardrop shape by the pulsar's gravity, its outer layers boiling away into a vast cloud of plasma that trails behind it like a cosmic comet's tail. This ongoing cannibalism serves a profound scientific purpose. As the pulsar feeds, it allows for measurements of staggering precision. The timing of the pulsar's lighthouse flashes is exquisitely regular, but as the stars orbit, that timing changes slightly due to the Doppler effect, the same phenomenon that makes a siren's pitch change as it passes by. By tracking these minuscule variations with atomic clock accuracy, astronomers can map the orbit in exquisite detail. This, in turn, lets them weigh the pulsar itself. The Black Widow pulsar is one of the most massive neutron stars ever found, a critical data point at the very edge of what physics says is possible for such an object before it collapses into a black hole. It is a laboratory of extremes where gravity, particle physics, and plasma dynamics collide. The system's fate is written in its present violence. In perhaps a few 100 million years, the companion star will be completely evaporated, leaving behind only the bloated, ultramassive pulsar and a faint, expanding nebula of its mates remains, a stark monument to a relationship that was, from the beginning, a death sentence. That intimate dance of stellar cannibalism is a microcosm of a far grander galactic-scale feast. In the constellation Perseus, a cosmic fossil hangs suspended in time, a relic of the universe's most violent youth. This is the galaxy NGC 1277, and it is a paradox frozen in light that has traveled for over 200 million years to reach us. From the outside, it resembles a typical massive elliptical galaxy, a dense swarm of ancient stars. But peer into its history, and you find a timeline that stopped abruptly. This galaxy formed almost all of its stars in a furious burst more than 10 billion years ago, and then, mysteriously, it simply shut down. It has not created any significant number of new stars since the universe was in its infancy, making it a pristine relic, a living snapshot of what the first giant galaxies looked like. In a cosmos where most large galaxies continuously recycle gas and spark new stellar generations, NGC 1277 is a silent, red and dead monument to an era long past. Yet, within this dormant giant lies an even more shocking secret. At its heart is a supermassive black hole of almost unimaginable proportions. While most galaxies have central black holes that make up about 0.1% of the galaxy's central bulge mass, the behemoth in NGC 1277 is an outrageous outlier. It contains a staggering 14 billion times the mass of our Sun, accounting for a jaw-dropping 14% of its entire galaxy's mass. It is as if a single organ made up most of a body's weight, a gravitational tumor of impossible size. How could such a monstrous black hole exist inside a galaxy that otherwise stopped growing eons ago? The leading theory paints a picture of a rapacious, chaotic past. In the dense, crowded environment of the early universe, proto-galaxies collided and merged with terrifying frequency. NGC 1277 may have been a dominant predator in its cluster, a galactic cannibal that gorged itself on smaller neighbors during the cosmic dawn. In this feeding frenzy, the central black holes of the devoured galaxies would have spiraled inward and merged with the core monster, fattening it to its extraordinary size. The violence of this process could have had a devastating side effect. As gas and dust funneled toward the growing black hole, it would have ignited as a searing quasar, blasting the galaxy with so much energy that it sterilized the remaining star-forming fuel, blowing it away into intergalactic space and quenching star birth forever. The galaxy and its black hole reached a morbid equilibrium. The very act of growing the monster killed the host's future. Studying NGC 1277 is like opening a time capsule from the universe's first few billion years. It challenges the standard, orderly story of galactic evolution, where black holes and their host galaxies grow in lockstep over cosmic time. Here, the black hole raced ahead, its growth spurt triggered by a period of extreme violence that left its galaxy frozen in time. It forces astronomers to ask whether this relic represents a failed evolutionary path, a galaxy that burned too bright too fast and died young, or if it is a missing link, showing us how the very first supermassive black holes achieved their staggering size through relentless, ancient cannibalism. The monstrous black hole of NGC 1277 grew fat on ancient violence, but our own galactic neighborhood holds a star whose recent, dramatic change was visible to the naked eye. Betelgeuse, the brilliant red supergiant that marks Orion's shoulder, began to falter. In late 2019, astronomers and stargazers alike watched in disbelief as one of the sky's most recognizable stars grew noticeably dimmer. Week by week, its fiery crimson glow faded, losing nearly 2/3 of its normal brightness by February 2020. For a star that is a cornerstone of our winter sky, this was not a subtle flicker in a telescope's data. It was a profound dimming anyone could see, a celestial landmark suddenly turning down its light. The immediate thrilling speculation was that we were witnessing the prelude to a supernova. Betelgeuse is a massive star, perhaps 800 times the diameter of our Sun, and it is in the final act of its life. Astronomers know it will explode someday, and the dramatic fading seemed to fit theories about what happens just before such a cataclysm. The star's outer layers could be collapsing inward, or its core might be undergoing a final, frantic fusion. For a few months, the world watched the sky, wondering if we were about to see the most spectacular stellar explosion in recorded human history, a daytime star that could outshine the moon. But Betelgeuse had other plans. As telescopes across the globe and in space trained their instruments on the star, a different story emerged. The star's surface temperature had not increased as expected for an imminent core collapse. Instead, combined data from the Hubble Space Telescope and other observatories revealed the likely culprit, a colossal stellar sneeze. Betelgeuse is a turbulent, bubbling cauldron. Massive convection cells, like boiling pots larger than our entire solar system, churn its outer layers. The evidence suggests one of these enormous upwellings ejected a titanic plume of superheated gas from the star's southern hemisphere. This material traveled into the cooler regions of space, where it condensed into an immense cloud of solid dust, trillions upon trillions of microscopic grains of silicate and carbon. From our vantage point on Earth, this newly formed cosmic cloud drifted directly in front of the star, acting like a vast, dark shade and dimming its light. It was a natural, if spectacular, event in the life of a dying star, not its final death throes. The star has since returned to its normal brightness, but the event was a scientific gift. It provided an unprecedented, real-time look at the mechanics of mass loss in a supergiant. We witnessed, in incredible detail, how these stars literally shed their own skins, seeding the surrounding space with the heavy elements forged in their cores. This dust will one day become part of new stars, planets, and perhaps even life. The great dimming of Betelgeuse reminded us that the cosmos is dynamic and that even the most familiar points of light are not permanent fixtures, but active, evolving engines whose final, brilliant demise could still happen tomorrow or 100,000 years from now. The mystery of Tabby's star demanded more than speculation. It demanded relentless observation. In the years following its discovery, a global network of telescopes, including the robotic eyes of the Las Cumbres Observatory, kept an almost constant vigil on that distant point of light. They were waiting for another dimming event, and when it came, they were ready to capture its spectral fingerprint, the precise breakdown of its light. This data held the key. If the dimming was caused by an opaque, solid megastructure, it would block all wavelengths of light equally, like a shutter sliding closed. But the new observations revealed something different. The dimming was chromatic. It was more pronounced in blue light than in red light. This is the telltale signature of dust. Tiny particles, smaller than a grain of flour, scatter shorter blue wavelengths more effectively than longer red ones, letting the redder light pass through more easily. The evidence was clear and consistent across multiple dimming episodes. The culprit was not a solid armada of solar panels, but a vast, swirling cloud of asymmetric dust, orbiting the star in a complex, clumpy ring. This dust, however, was no ordinary cosmic grit. Its properties are profoundly strange. For it to cause such deep, irregular dimming, the dust particles must be extremely fine, essentially microscopic. Larger grains or uniform particles would not produce the observed light patterns. Furthermore, the dust must be unevenly distributed, forming dense patches and sparse zones, which explains why the dimming events were so chaotic and unpredictable. The leading theory now suggests a family of exocomets, perhaps disrupted by the gravity of an unseen planet. continuously grinding themselves into this fine, obstructive haze. So, the most extraordinary hypothesis, the alien megastructure, has been set aside by the weight of evidence, yet this is not a disappointing end to the story, but a triumphant display of how science works at its best. An initial, breathtaking idea captured the public's imagination and, more importantly, focused intense scientific scrutiny on a truly anomalous star. That scrutiny, guided by curiosity rather than conviction, gathered the data that refined our understanding. We moved from a single, sensational possibility to a more nuanced, and in many ways more intriguing, reality. Tabby's star remains bizarre, a stellar oddball with a penchant for casting deep, dusty shadows, but its lesson is universal. The universe is under no obligation to conform to our wildest dreams, yet its natural truths, revealed through patience and precision, are often more wondrous than any fiction we could invent. While we watch our own stars for signs of change, the cosmos can also send visitors from unimaginable distances. In October 2017, a telescope in Hawaii detected a faint point of light moving at impossible speed. It was not orbiting the Sun, it was falling through our solar system on a hyperbolic trajectory, a path that meant it came from the void between stars and would return to it. Astronomers named it Oumuamua, Hawaiian for scout, and it became the first confirmed interstellar object ever observed within our own celestial neighborhood. Its arrival was a historic moment, but its behavior was what truly captivated and confounded scientists. As telescopes scrambled to observe it, they pieced together a portrait of a profoundly bizarre traveler. First, there was its shape. By analyzing how its brightness changed dramatically as it tumbled, astronomers deduced it was not spherical. It was wildly elongated, with estimates suggesting it was at least 5 to 10 times longer than it was wide. Some models even suggested a flattened, pancake-like form. This was unlike any known asteroid or comet from our own solar system, which tend to be more lumpy or rounded. Second, it lacked the defining feature of a comet, a visible coma. As comets approach the Sun, their ices heat up and vaporize, creating a glowing cloud of gas and dust around the nucleus. Oumuamua showed no such cloud, even when it made its closest pass to the Sun. It appeared as a bare, dark, and inert rock, more like an asteroid. But then came the third and most puzzling characteristic: it accelerated. As Oumuamua sped away from the Sun, its path was tracked with extreme precision. The laws of gravity dictated exactly how fast it should be moving under the Sun's pull alone. Yet, the data revealed a tiny but undeniable extra push, a non-gravitational acceleration that made it move just a fraction faster than it should have. This is something comets do, as jets of vaporizing gas act like natural rocket engines, but Oumuamua had no visible coma, no detectable gas or dust streaming off it. So what was pushing it? The debate ignited immediately. One camp argued it must be a comet after all, an exotic one from another star system. Perhaps its ices were hidden beneath a thick, insulating crust, and the gas jets that provided the thrust were so narrow and clean they were invisible to our telescopes. Another idea proposed it was a fragment of a Pluto-like planet, a shard of solid nitrogen ice chipped off in some distant cataclysm. As the Sun's heat vaporized the nitrogen from its surface, it would have produced the needed thrust without creating a dusty coma. But the most provocative explanation came from Harvard astronomer Avi Loeb. He argued we should consider the possibility, however slim, that Oumuamua was a piece of advanced technology, a light sail. A light sail is a theoretical spacecraft propulsion method that uses the gentle but constant pressure of sunlight for thrust, much like a boat's sail uses wind. Loeb noted that the object's unusual flat shape, its extreme reflectivity, and its precise acceleration away from the Sun were all consistent with a thin, lightweight sail drifting through the galaxy. He suggested it could be a derelict artifact, a piece of broken equipment from a civilization far away. The scientific community largely favors natural explanations, emphasizing that we should not invoke extraordinary causes for phenomena we are just beginning to understand. Oumuamua's true nature remains an open question, as it has now vanished into the depths, far beyond the reach of any probe, but its legacy is undeniable. It proved that interstellar objects are passing through our solar system all the time. We simply lacked the technology to see them. It opened an entirely new field of astronomy, prompting missions to be planned for intercepting the next such visitor. Oumuamua was a silent scout from a foreign star, a cosmic postcard we had only a fleeting moment to read, and its message was clear: we are not alone in our isolation. The galaxy is a dynamic place, and it is sending us samples. If Oumuamua was a silent scout, then the universe has also unleashed a rampaging giant. Astronomers using the Hubble Space Telescope have witnessed something previously thought impossible: a supermassive black hole with the mass of 20 million suns on the run. It is not sitting serenely at the heart of a galaxy. It is hurtling through intergalactic space at tremendous speed, and in its wake, it is not leaving a trail of destruction, but a chain of newborn stars. The image is almost surreal. This cosmic monster, an object so dense that not even light can escape its grasp, is racing through a vast corridor of thin gas. As it plows forward, the shock of its passage compresses the gas in front of it, and the violent turbulence in its wake triggers a cascade of stellar births. The black hole itself is invisible, a perfect shadow against the black of space, but its path is illuminated by a brilliant trail of young, blue stars stretching over 200,000 light-years, twice the diameter of our own Milky Way. It is a cosmic contradiction, a devourer of light acting as a midwife to suns. How could such a behemoth be ejected from its home? The answer lies in a rare and spectacular game of gravitational billiards involving 3 galaxies. Imagine a dance of giants. When 2 galaxies merge, their central supermassive black holes will eventually spiral toward each other, drawn together by gravity and friction with surrounding stars and gas. They orbit closer and closer until they finally coalesce into a single, larger black hole. This merger releases a titanic burst of gravitational waves, ripples in the fabric of spacetime itself. Normally, this energy is emitted symmetrically, and the newly formed black hole stays put, but introduce a third player. The Hubble discovery suggests the runaway black hole was once part of a triple system. As 3 galaxies merged, their 3 central black holes engaged in a chaotic gravitational tango. When 2 of them finally merged, the burst of gravitational waves could have been lopsided, shooting the newly formed monster in the opposite direction. Think of firing a rifle. The bullet flies forward because the explosion pushes backward against the gun. In this cosmic analogy, the asymmetric blast of gravitational waves acted as the explosion, and the merged black hole became the bullet, kicked clean out of the galactic core at speeds that could reach millions of miles per hour. The discovery shatters a long-held assumption that these supermassive objects are permanent, stationary anchors at the center of their galaxies. They can be unmoored. They can become cosmic nomads, wandering the voids between galaxies. This has profound implications. It suggests there could be many such rogue black holes drifting unseen through the darkness, each one a gravitational ghost from some ancient, catastrophic merger. And in a twist of cosmic irony, this particular fugitive is not a bringer of death in its new domain. By compressing the thin gas it encounters, it is creating stellar nurseries, forging new suns in a region of space that would otherwise remain dark and barren. It is a stunning reminder that in the universe, the most violent events can sometimes yield the most beautiful and unexpected consequences. That runaway black hole is a cosmic fugitive, but some mysteries are not objects in motion, but permanent scars etched into the very first light of the universe. In the faint ancient glow that fills all of space, known as the cosmic microwave background, there is a blemish. Astronomers call it the cold spot, a vast region of sky in the constellation Eridanus that is significantly, mysteriously colder than the surrounding afterglow. To understand why this is so strange, we must first understand what this light represents. The cosmic microwave background is the oldest photograph we have, the remnant heat from the Big Bang itself, released when the universe was just 380,000 years old. It is the ultimate baby picture of the cosmos, and for the most part, it is remarkably smooth and uniform, a testament to the universe's hot, dense, and even beginnings. Tiny, random fluctuations in this temperature map, mere millionths of a degree, are the seeds from which all galaxies and clusters would eventually grow. But the cold spot is not a tiny fluctuation, it is a colossal anomaly, a patch of sky spanning over 1 billion light-years across where the temperature dips far more than our standard models of cosmic evolution can easily explain. It is a cosmic bruise that should not be there. The most straightforward explanation points to a supervoid, an unimaginably vast region of space that is mostly empty. If the cold spot sits in the direction of such a void, the light from the cosmic microwave background passing through it could lose energy due to a subtle effect called the integrated Sachs-Wolf effect. Think of it like climbing out of a deep well. Light loses energy as it escapes a gravitational depression, making it appear slightly colder. The problem is one of scale. Even the largest known voids, like the Boötes void we discussed earlier, are not nearly big enough or empty enough to create a temperature dip as profound as the cold spot. Surveys have found some under dense regions in that direction, but nothing that matches the staggering size required by the anomaly. It is as if we found a footprint, but the creature that made it would have to be a giant far larger than anything we have ever seen. This mismatch between the observed void and the needed void has led cosmologists to consider a truly spectacular possibility. Could the cold spot be the imprint of a collision with another universe? In the framework of the multiverse, our cosmos is one bubble in an infinite, frothing sea of other bubble universes, each with potentially different physical laws. If during the universe's violent inflationary expansion phase, our bubble brushed or collided with a neighboring one, the energy of that collision could have left a distinct signature in the cosmic microwave background, a circular region of altered temperature. The cold spot size and profile could, in theory, match such a cosmic bruise. This is, of course, a highly speculative idea sitting at the very edge of testable physics. Yet its profound implication is what captures the imagination. The cold spot may be more than just a statistical fluke or an unexplained void. It could be a fingerprint, a tangible piece of evidence that our universe is not alone, that the totality of reality extends far beyond the cosmic horizon we can observe. It is a tantalizing hint that the greatest structure in the universe might not be a galaxy or a cluster, but the scar from a primordial encounter with another reality entirely. The idea of a collision between universes is a staggering thought experiment, but the cosmos also creates treasures on a more intimate, dazzling scale. Orbiting a dead star in the constellation Serpens, over 4,000 light-years away, is a world of almost pure fantasy. Astronomers have designated it PSR J1719-1438b, but its popular name captures the imagination perfectly: the Diamond Planet. This is not a metaphor. Based on its mass, density, and the system's violent history, scientists are confident this planet is largely composed of crystallized carbon. It is, in essence, a cosmic jewel of almost unimaginable size and value. Its story begins with a catastrophic partnership. The planet orbits not a normal sun, but a pulsar, the rapidly spinning, ultra-dense remnant of a supernova. This particular pulsar spins over 10,000 times per minute, a dizzying celestial metronome. The planet is so close to this stellar corpse that it completes an entire orbit in just 2 hours and 10 minutes. To put that in perspective, a year on this world is shorter than a single Earth morning. This proximity is the key to understanding its bizarre composition. Astronomers believe the Diamond Planet was not always a solid world. It was likely once a massive star itself, or the helium-rich core of a giant star, locked in a tight binary dance with the star that would become the pulsar. When that companion star went supernova, the resulting pulsar began a relentless assault. Its intense gravity and searing radiation began to siphon away the outer layers of the surviving star, stripping it down atom by atom over millions of years. This process left behind only the star's incredibly dense core, an object about the size of Jupiter but with over 300 times its mass. This core, under unimaginable pressure and heat, would have been composed primarily of carbon and oxygen, the ash of nuclear fusion. As the remnant cooled over eons, the carbon under pressures millions of times greater than Earth's atmosphere crystallized. The result is a planetary mass diamond, perhaps thousands of miles in diameter. We cannot see it directly. Its existence is inferred from the exquisitely regular timing of the pulsar's radio pulses, which are minutely disturbed by the planet's gravitational tug. This detection method itself is a marvel of precision, allowing us to weigh the planet and deduce its nature from afar. The Diamond Planet is more than a cosmic curiosity. It is a direct window into the most extreme outcomes of stellar evolution. It proves that planetary systems can form from the ashes of stellar cataclysms, giving rise to worlds with compositions we could never find in our own solar system. It challenges our very definition of a planet and expands the catalog of possible worlds to include the truly exotic. If such a place can exist, what other impossible treasures might be waiting in the dark, orbiting the corpses of dead stars? A celestial hand seems to reach from the grave, its skeletal fingers stretching across 150 light-years of space. Captured by the Chandra X-ray Observatory, this is the so-called Hand of God Nebula, a ghostly visage glowing with the energy of a dead star. The image is not a cosmic pareidolia, a simple trick of perception. It is a direct portrait of physics in its most extreme form, a pulsar wind nebula sculpted by invisible forces. At the heart of this phantom limb lies a pulsar known as PSRB 1509-58, the rapidly spinning corpse of a massive star that exploded roughly 1,700 years ago. This neutron star, little larger than a city, spins 7 times every second, and with each rotation, it acts as a dynamo of unbelievable power. It generates a fierce wind of high-energy electrons and positrons, particles accelerated to nearly the speed of light. This relentless stream plows into the cloud of debris left behind by the supernova, the star's own remains. Here is where the magic happens. The pulsar is also a powerful magnet, and its intense magnetic field channels and confines these escaping particles. Like water forced through a hose, the particles flow along the magnetic field lines, causing them to glow brilliantly in X-ray light. The complex structure of the field, combined with the uneven distribution of the supernova debris, shapes the outflow into those haunting, elongated fingers and palm-like structures. We are witnessing a cosmic feedback loop of death and creation. The star's violent end provided the raw material, and its collapsed core now energizes that material, lighting it up in a spectral display. The particles within this nebula are some of the most energetic ever detected, a natural particle accelerator on a galactic scale. The hand of God is a perfect marriage of the eerie and the empirical, a reminder that the universe's most haunting beauty is often just the visible signature of forces we are only beginning to comprehend. These ghostly fingers are sculpted by a dead star's magnetic field, but another new eye on the sky is seeing structures so vast they threaten to redraw cosmic history itself. The James Webb Space Telescope, humanity's most powerful time machine, has peered back to the universe's first few 100 million years and found a gallery of impossibilities. These are galaxies, but not as our theories predicted. They appear too massive, too bright, and too mature to exist in such a young cosmos. Nicknamed universe breakers, they glow with the light of billions of stars that, according to our standard timeline, should not have had time to form. One of the most startling examples is a galaxy designated GZ11. It existed when the universe was only about 300 million years old, a mere infant by cosmic standards. Yet, based on its luminosity, it appears to contain several 100 million times the mass of our Sun in stars. To build such a colossal structure so quickly, stars would have had to form at a rate hundreds of times faster than we see in our own mature Milky Way today. It is as if archaeologists, digging in the ruins of an ancient civilization, found a fully formed skyscraper in a layer of Earth dating to the Stone Age. The timeline simply does not fit. Our prevailing model of cosmology, known as the lambda cold dark matter model, is a remarkably successful recipe for how the universe evolved from a smooth, hot soup after the Big Bang into the intricate web of galaxies we see today. It includes precise predictions for how quickly matter clumped together under gravity, how dark matter provided the scaffolding, and how long it took for the first stars and galaxies to ignite. The galaxies Webb is finding are not just a little ahead of schedule, they are crashing the party eons early, suggesting that either the ingredients or the cooking instructions in our cosmic recipe are fundamentally wrong. Astronomers are scrambling for explanations. One possibility is that our understanding of early star formation is incomplete. Perhaps the first stars were not like the ones we know. They might have been monstrously large, population 3 stars, hundreds of times more massive than our Sun. These behemoths would burn ferociously bright and die young in spectacular supernova, flooding their galaxies with light and heavy elements far more efficiently than the slower, steady pace of star birth we see today. Their intense luminosity could make a relatively small collection of stars look, from our distant vantage point, like a galaxy of immense mass. Another, more radical idea touches on the nature of dark matter itself. What if the dark matter in the early universe was not cold and slow-moving, but slightly warm, allowing it to clump into dense halos much faster than our models allow? This would give normal matter a gravitational head start, accelerating galaxy assembly to breakneck speeds. There is even the humbling possibility that we are misreading the data altogether, that dust or other effects are reddening and dimming the light of these galaxies in ways we do not yet understand, making them seem more distant and therefore earlier than they truly are. The profound beauty of this moment is its uncertainty. The James Webb Space Telescope was built to see the universe's first light, and in doing so, it has immediately presented us with cosmic paradoxes that shake the foundations of our knowledge. These impossible galaxies are not failures of theory, they are the thrilling first notes of a new symphony of discovery. They prove that the universe, even in its infancy, was capable of feats we have yet to dream of, and that every time we build a better window to the cosmos, we must be prepared for it to show us a universe stranger than we imagined. The impossible galaxies seen by the James Webb Telescope challenge our timeline, but another, more subtle motion threatens to redraw our cosmic map entirely. Astronomers have detected a strange, coordinated drift on the largest scales imaginable, a phenomenon they call the dark flow. Across billions of light years, entire clusters of galaxies, each containing thousands of island universes, are streaming together in the same direction, as if caught in a vast, invisible current. This is not the general expansion of space. This is a peculiar motion, a shared velocity superimposed on the cosmic backdrop, and it points to something immense pulling from beyond the edge of everything we can see. The evidence comes from a meticulous study of the universe's oldest light, the cosmic microwave background. As the hot gas within these gigantic galaxy clusters moves through space, it scatters the photons of this ancient afterglow in a specific way, an imprint known as the kinetic Sunyaev-Zeldovich effect. By measuring this subtle distortion, scientists can calculate the cluster's bulk motion relative to the universal rest frame. When they did this for hundreds of clusters, the results were staggering. The clusters were all moving coherently at speeds of over 2 million miles per hour toward a region of sky between the constellations Centaurus and Vela. This direction is different from the pull of the Great Attractor, which is a local structure. The dark flow suggests an influence from far, far beyond our cosmic neighborhood. The implication is as profound as it is unsettling. The observable universe, the sphere of space from which light has had time to reach us since the Big Bang, is about 93 billion light years across. According to standard cosmology, nothing outside that horizon should be able to affect the matter inside it, as no signal, not even gravity, can travel faster than light. Yet the dark flow hints that something of unimaginable scale, lying far past our cosmic horizon, is exerting a gravitational tug on everything we can see. What could possibly be massive enough to do that? One speculative theory points to the gravitational pull of another universe-sized structure, a neighboring bubble in a multiverse, whose immense mass warps the fabric of reality on a scale we can barely conceive. Another, even more radical idea suggests it could be an imprint from the universe that existed before our own Big Bang, a relic motion from a prior cosmic cycle. Not surprisingly, the finding has sparked fierce debate. Skeptics argue it could be a statistical fluke, an artifact of incomplete data, or a subtle calibration error in how we measure the cosmic microwave background. Others propose less exotic explanations, like undiscovered, large-scale structures within our observable universe that are pulling matter in a uniform way. The controversy is a healthy part of the scientific process, a rigorous stress test for an extraordinary claim. Whether the dark flow is ultimately confirmed or refuted, its very proposal forces us to confront a humbling possibility. Our entire observable cosmos, with its hundreds of billions of galaxies, might not be a self-contained island. It could be adrift in a far grander ocean, pulled by tides generated in realms we may never see, a clue written in the motion of galaxies that the story of existence does not end at the edge of our vision. A relic from the dawn of time orbits quietly in our own galactic backyard, designated SDSS J102915 plus 172927. This ancient star in the halo of the Milky Way holds a composition so pure it defies the story of cosmic beginnings. It is composed almost entirely of hydrogen and helium, with a metal content so astonishingly low it is over 20,000 times poorer in heavy elements than our own Sun. In astronomical terms, metals refer to any element heavier than helium, the building blocks forged in stellar furnaces and scattered by supernova. This star, however, is a pristine fossil, a celestial artifact from an era before such pollution existed. According to our best models of the early universe, it should not be here. The prevailing theory of first star formation, known as population 3 stars, states that the very first generation of suns needed a crucial ingredient to ignite. In the primordial universe, the only elements were hydrogen, helium, and a trace of lithium. Gas clouds of just these elements are extremely inefficient at cooling down. To collapse under their own gravity and trigger nuclear fusion, a cloud needs to shed heat to radiate energy away. Heavier elements, even in minuscule amounts, act as a cosmic coolant. Atoms like carbon and oxygen can emit infrared radiation as they collide, allowing the cloud to contract. Without these trace metals, the gas would simply remain too hot and too diffuse, forever resisting the gravitational pull needed to birth a star. SDSSJ102915 plus 172927, with its nearly undetectable metal signature, sits squarely in this forbidden zone. By all rights, it should never have condensed. Its existence is a direct challenge, a cosmic paradox shining in the present day. So how did it form? Astronomers are forced to consider radical alternatives. Perhaps the first stars were not all monstrous giants that died quickly. Maybe some small, fragile stars formed in rare, dense pockets of the early universe where gravity won out against the heat, creating long-lived dwarfs that have burned quietly for over 13 billion years. This star could be a surviving member of that elusive first generation, a true population 3-star we thought had vanished entirely. Another possibility is that our understanding of cooling is incomplete. Could dark matter have played a role? Some exotic models suggest that interactions between normal matter and dark matter particles in the early universe could have provided an alternative cooling mechanism, allowing metal-free gas to collapse. Or perhaps the star formed from the remnant of a single, gargantuan first star's supernova, a blast so peculiarly tuned that it ejected mostly pure hydrogen and helium back into space, which then recollapsed into this second-generation oddity. Every option requires tweaking the foundational narrative. This faint star is more than a curiosity, it is a key to the universe's first chapters. By studying its precise composition, its motion, and its subtle pulsations, astronomers are reading an autobiography written in the simplest elements. It forces a humbling admission: the cosmos's infancy may have been more varied, more creative, and more mysterious than our elegant theories have allowed. In its ancient, pristine light, we are seeing not just a star, but a glimpse of a lost era, a silent witness to the moment when the darkness first began to spark. While ancient stars tell tales of the universe's birth, our own planet was recently caught in a storm of a completely different kind. High above the North Pole, where the thin air of the upper atmosphere meets the void of space, scientists witnessed something unprecedented: a hurricane, but not one made of clouds and rain. This was a space hurricane, a 600-mile wide swirling vortex of plasma, churning silently in the ionosphere and raining electrons down toward the Earth below. It was a new type of cosmic weather, a phenomenon predicted by theory but never seen until it was spotted in satellite data from August 2014. The discovery came not from a dramatic visual image, but from a meticulous analysis of observations from 4 weather satellites that happened to be passing information over the Arctic. Their instruments painted a startling picture. Instead of a typical, chaotic plasma flow, the data revealed a distinct spiral structure with multiple arms, a quiet center like an eye, and widespread electron precipitation, a downpour of charged particles. It was a perfect giant cyclone, but one composed entirely of electrified gas, or plasma, and it rotated counterclockwise, just like a northern hemisphere tropical storm. This eerie calm at the center, surrounded by a violent, circulating flow, is the hallmark of a hurricane, and here it was, playing out 80 miles above the ground in a realm with almost no air at all. The engine for this space hurricane was not warm ocean water, but the relentless stream of charged particles from the Sun, the solar wind, during a period of unusually steady northward orientation of the interplanetary magnetic field, energy from the solar wind was transferred efficiently into Earth's upper atmosphere through a process called magnetic reconnection. This influx of energy and charged plasma interacting with our planet's own magnetic field created the conditions for a vast, sustained vortex to form. It swirled for nearly 8 hours, a testament to a delicate and powerful balance of forces in near-Earth space. The implications of this discovery are profound. For decades, scientists have known that energy from the Sun constantly buffets Earth's magnetic shield, creating dynamic space weather like the auroras. The space hurricane, however, represents a previously unknown mode of this energy transfer. It shows that under specific, stable conditions, that energy can organize itself into a large-scale, coherent, and surprisingly structured system, much like how warm seawater organizes atmospheric chaos into a spinning hurricane. This forces a re-evaluation of the Sun-Earth connection, suggesting that the coupling between the solar wind and our planet's atmosphere can be far more orderly and complex than we realized. This finding immediately opens a new chapter in planetary science. If a space hurricane can occur over Earth, could they also rage in the skies of other worlds? The ingredients seem universal: a planetary magnetic field, an atmosphere or ionosphere, and a stellar wind. Gas giants like Jupiter and Saturn, with their powerful magnetic fields and constant bombardment from the solar wind, could be prime candidates for even more colossal space hurricanes. Our own moon, lacking a global magnetic field, likely cannot host them, but a magnetized world like Mercury might experience fleeting, small-scale versions. The discovery adds a Chinese letter entry to the cosmic forecast, reminding us that weather is not limited to the lower atmosphere. The universe is filled with invisible tempests, storms of pure magnetism and charged particles, silently shaping the environments of worlds across the galaxy. These invisible tempests in our own sky are a reminder that the universe is full of phenomena we can only detect with the right kind of eyes. In 2019, a new set of radio eyes opened wide, and they immediately saw something that should not be there. Astronomers using the Australian Square Kilometre Array Pathfinder, a powerful radio telescope, were conducting a vast survey of the sky when they spotted faint, ghostly rings. They were perfect circles, some so large they could contain entire galaxies within their boundaries, yet they were completely invisible to every other type of telescope: optical, infrared, even X-ray. The Discovery team, with a perfect blend of precision and bewilderment, named them odd radio circles, or ORC. They are not supernova remnants, not planetary nebulas, not any known type of radio galaxy. They are something entirely new, a class of object that seems to exist only as an echo in the radio spectrum, and their scale is almost incomprehensible. A single ORC can span over 1 million light-years, meaning light would need 1 million years to travel from one side of this faint ring to the other. They are structures on a galactic scale, but they are not made of stars. They are made of something far more elusive: synchrotron radiation. This is the light emitted by electrons spiraling at nearly the speed of light around magnetic field lines. The rings glow with this specific signature, telling us that within these vast circles, there are powerful magnetic fields and populations of ultra-high-energy particles. But what event could possibly create such an immense, circular, and magnetized shockwave in intergalactic space? The leading theory is as violent as it is spectacular. It points to the aftermath of the universe's most energetic mergers, the collision of two supermassive black holes. When the central black holes of two merging galaxies finally spiral together and coalesce, they release a tsunami of gravitational waves. This titanic release of energy could, in theory, send a colossal spherical shockwave blasting out through the surrounding intergalactic gas, a bubble expanding at a significant fraction of the speed of light. As this bubble plows through the thin plasma that fills the spaces between galaxies, it would accelerate particles and amplify magnetic fields, creating exactly the kind of luminous radio ring we see. The ORC would be the fossilized imprint of that cataclysm, a billion-year-old echo of a moment when two galactic hearts became one. Another, far more speculative idea ventures into the realm of theoretical physics. Could these perfect circles be something even more exotic, like the throats of wormholes? In some highly advanced models, a traversable wormhole, a tunnel through spacetime, might be surrounded by a sphere of highly magnetized plasma. If we were to look down the throat of such a structure face on, it might appear as a circle. While this is a fringe hypothesis, it speaks to the profound mystery these objects represent. They are so strange that they naturally invite the most extraordinary explanations. What makes ORCs particularly tantalizing is their timing. They are a discovery of the modern era of big data astronomy. Wide-field radio surveys are now mapping the sky with unprecedented speed and sensitivity, and in that flood of new data, we are finding patterns and objects we never knew to look for. The ORCs are a signature of this new age. They were always there, faintly painting giant circles on the cosmic canvas, but we lacked the instruments to see them. Their existence tells us that even after centuries of observation, the universe is still capable of presenting us with entirely new categories of the bizarre, enormous puzzles written in a language of radio waves, waiting just beyond the edge of our ordinary sight. Deep within the invisible spectrum of X-rays, a monster has a pulse. In the constellation Aquila, a binary system named Jaris 1915+105 hosts a stellar mass black hole locked in a deadly embrace with a normal star. As the black hole's immense gravity strips gas from its companion, that material does not fall straight in. Instead, it spirals into a flat, superheated structure known as an accretion disk, a whirlpool of plasma orbiting at nearly the speed of light. And within that maelstrom, astronomers have detected something profoundly strange, a rhythmic, repeating flicker in its X-ray output that beats with the eerie regularity of a cosmic heart. This is not a steady signal, it is a quasi-periodic oscillation, a heartbeat that repeats roughly every 50 minutes, but with a subtle, organic irregularity that makes it feel alive. The X-ray luminosity rises and falls, in a cycle that has persisted for decades. To understand this pulse, we must peer into the most violent environment in the universe, the region just outside the black hole's event horizon. The leading explanation is a process of accumulation and release, a traffic jam in the flow of spacetime itself. Imagine the inner edge of the accretion disk as a precipice. As gas spirals inward, it can encounter a point where the pull of gravity and the outward pressure of radiation reach a tense standoff. Material piles up here, like water behind a dam. This growing mound of superheated plasma grows hotter and denser until suddenly the pressure becomes too great. The dam breaks, the accumulated material plunges catastrophically into the black hole all at once, releasing a tremendous burst of X-rays. Then the process begins anew, the disk refills, the material piles up, and another pulse is born. This heartbeat is a direct probe of the churning geometry of warped spacetime. The rhythm is dictated by the orbital dynamics at the very inner edge of the disk, a region where Einstein's predictions are tested to their limit. The slight variations in the timing and strength of each pulse are like a doctor listening to a murmur, revealing the complex physics of how energy and matter behave under conditions of unimaginable gravity. It shows us that the vicinity of a black hole is not a smooth, silent descent into darkness, but a turbulent, dynamic ocean where space and time are stirred into a frenzy. This microquasar's persistent pulse is a unique laboratory, allowing us to study the final moments of matter's journey in a way that no static observation ever could. It is a reminder that even the most voracious objects in the cosmos can exhibit a strange, predictable cadence, a heartbeat echoing from the edge of oblivion. That heartbeat from a black hole's edge is a drumbeat of violence, but our own galaxy holds a star that has already screamed. In the 1840s, a faint point of light in the constellation Carina, visible only from the southern hemisphere, began to change. The star Eta Carinae, already known to be unstable, erupted. Over the course of years, it brightened until, by 1843, it became the second brightest star in the entire night sky, outshone only by Sirius. This was not a quiet flicker, it was a stellar catastrophe in slow motion, a supernova imposter event that released as much visible light as a true supernova, yet the star somehow survived. For over a decade, it blazed with this terrifying intensity, a beacon of chaos that would have been visible even in daylight to anyone below its horizon, before finally fading back into obscurity. The cause was a titanic internal struggle. Eta Carinae is not one star, but a binary system with a primary star that is a true cosmic behemoth. It contains over 100 times the mass of our Sun, placing it right at the theoretical limit of what a star can be. Such a monster lives fast and dies young, burning through its nuclear fuel at a prodigious rate. In the 1840s, it reached a critical point. The radiation pressure from its furious fusion reactions became so intense that it began to overpower the star's own gravity. The outer layers of the star were literally being blown away by the light they produced. This resulted in the Great Eruption, a decades-long paroxysm where the star ejected an amount of material equivalent to 10 times the mass of our Sun. That ejected material did not just drift away, it formed one of the most beautiful and bizarre structures in our galaxy, the Homunculus Nebula. Today, thanks to telescopes like Hubble, we can see it in stunning detail. It is a bipolar cloud, a vast cosmic butterfly with two opposing lobes of gas and dust expanding outward from the central star at over 1 million miles per hour. The lobes are not smooth, they are etched with intricate ridges and valleys, the scars of a turbulent, messy explosion. At the heart of this glowing sculpture, the surviving star system still rages. The two stars orbit each other in a highly elliptical, 5.5-year dance that brings them perilously close. Every time they approach Periastron, their closest point, their fierce stellar winds collide, creating a shockwave that heats gas to millions of degrees and produces a predictable flare in X-rays. This system is a ticking time bomb on a human timescale. Eta Carinae is so massive and so unstable that astronomers believe its final death throes are imminent, not in billions of years, but perhaps within the next 100,000, maybe even the next 10,000. When it finally does go, it will not be a quiet supernova. Given its extraordinary mass, it is a prime candidate for a hypernova, an explosion orders of magnitude more energetic than a typical supernova, possibly accompanied by a long-duration gamma-ray burst, the most luminous electromagnetic events known in the universe. We have a front-row seat to this impending cataclysm. At a relatively close distance of about 7,500 light-years, its final explosion will be a spectacular celestial event, likely visible in broad daylight for months and bathing our solar system in a harmless but awe-inspiring glow. It will be a cosmic spectacle unseen on Earth since the supernova that formed the Crab Nebula in 1054. Eta Carinae is a warning light in our galactic neighborhood, a reminder that the universe is not a static museum, but a theater where the most dramatic acts are always waiting in the wings. Eta Carinae's impending violence is a testament to a universe built on titanic forces, but sometimes the most profound challenge comes not from what is present, but from what is missing. In the quiet constellation Cetus, a ghostly galaxy drifts, and its very existence threatens to unravel a cornerstone of modern cosmology. Designated NGC 1052-DF2, this ultra-diffuse galaxy is a wispy, translucent collection of stars, so sparse you could almost see straight through it. But its true strangeness is not its faintness, it is what astronomers could not find within it. This galaxy appears to have no dark matter at all. The discovery sent shockwaves through the field because dark matter is not just a minor component of the universe, it is the invisible scaffolding upon which everything is built. Our standard model of cosmology states that all galaxies, from majestic spirals to dwarf spheroids, are born within and held together by vast halos of this mysterious, unseen substance. Its gravity provides the extra pull needed to keep stars from flying apart given their observed speeds. Without it, our theories of galaxy formation simply do not work. So how do you weigh something you cannot see? Astronomers turn to the galaxy's globular clusters, bright, dense balls of ancient stars that orbit the galactic center. By measuring the velocities of these clusters with the Hubble Space Telescope and other instruments, scientists could calculate the total gravitational mass of the galaxy holding them in orbit. The result was stunning. The mass calculated from the motions of the clusters matched, almost exactly, the mass that could be accounted for by the visible stars alone. There was no room left for dark matter. It was as if you weighed a sealed box, shook it, and heard no sound from inside, concluding it was truly empty, a cosmic void where there should have been an anchor. The immediate thrilling question was whether this disproved dark matter entirely. Could alternative theories of gravity, which modify Einstein's equations to explain galactic rotations without invisible matter, finally be vindicated? The answer for most scientists is no, and the reason lies in a neighboring galaxy. NGC 1052-DF2 is not floating in perfect isolation. It lives near a massive elliptical galaxy called NGC 1052. This proximity provides a crucial clue. One leading theory suggests that DF2 was born from a very specific, violent process. During a chaotic collision between two gas-rich galaxies long ago, a torrent of gas could have been violently stripped out and flung into intergalactic space. This orphaned gas, never having been part of a stable dark matter halo to begin with, then slowly and quietly coalesced into stars, creating a galaxy made purely from normal baryonic matter. It is a cosmic foundling, assembled from material that lost its dark matter parent at birth. This makes DF2 not a refutation of dark matter, but a critical stress test for our models. Its existence forces astrophysicists to refine the story of galactic formation, to account for these rare but possible outliers that emerge from the universe's most violent interactions. It proves that the cosmos has more than one way to build a galaxy. Some are sculpted by the gentle accumulation of dark matter, while others, like this ghostly wisp, are the accidental children of celestial violence, born in a storm and left to drift, a silent challenge written in starlight and absence. This ghostly galaxy without dark matter shows the cosmos is full of surprises, and sometimes the most shocking discoveries are the ones we find in our own backyard. From our vantage point on Earth, deep within the Milky Way's spiral arm, our view toward the galactic center is obscured by thick lanes of dust and stars. But when scientists launched an instrument that could see in a completely different light, they unveiled a pair of colossal structures that had been hidden in plain sight for millions of years. In 2010, Data from the Fermi Gamma Ray Space Telescope revealed two enormous bubbles of ultra-hot gas ballooning out from the galactic core. They are perfect mirror images of each other, one extending north and one south of the galactic plane, together forming a symmetrical hourglass that stretches for an astonishing 50,000 light-years from tip to tip. To grasp that scale, our entire Milky Way galaxy is about 100,000 light-years wide. These Fermi bubbles, as they are now known, occupy half of that distance, a silent monument towering over our galactic neighborhood. They do not glow in visible light. They are invisible to our eyes and to optical telescopes. They reveal themselves only in the most extreme form of energy, high-energy gamma rays. This tells us the bubbles are filled with particles moving at nearly the speed of light, cosmic rays that slam into the thinner gas of the galactic halo, creating the brilliant gamma ray glow that Fermi detected. The discovery was a complete surprise. No model of our galaxy had predicted such immense, coherent structures. Their sheer size and perfect symmetry point to a single, catastrophic event, a titanic explosion that punched through the galaxy's disk from the core, blowing these bubbles into intergalactic space. The prime suspect sits at the very center of the hourglass, our galaxy's own supermassive black hole, Sagittarius A star. Today, Sagittarius A star is relatively quiet, a sleeping giant. But the Fermi bubbles are the fossil record of a time when it woke up. The leading theory suggests that several million years ago, a massive cloud of gas or a star ventured too close and was torn apart by the black hole's gravity. This feeding frenzy would have unleashed a cataclysmic jet of energy and matter, a bipolar outburst that shot perpendicularly out of the galactic disk. For tens of thousands of years, this jet would have blasted outward, inflating the bubbles like a cosmic bellows and filling them with accelerated particles. The event would have been unimaginably violent, a brief but brilliant flare that would have outshone the entire galaxy, visible to any observer in the local group. Yet, from our safe distance of 26,000 light-years, life on Earth was utterly unaffected, evolving quietly beneath this silent, expanding cathedral of energy. The bubbles are a permanent scar, a reminder that our seemingly calm and orderly spiral galaxy has a deeply violent past. They force us to see the Milky Way not as a static home, but as an active, evolving entity with a heartbeat of its own, capable of eruptions that reshape its very structure on a scale we are only beginning to comprehend. From silent radio screams to galaxies that should not exist, this journey through 25 cosmic enigmas reveals a universe of breathtaking chaos and wonder. Each bizarre event, from the star that vanished to the impossible galaxies seen by the James Webb Telescope, shares a common, thrilling truth: the cosmos is not a serene, static backdrop. It is a dynamic, evolving, and profoundly strange arena where the rules are constantly being rewritten by the next observation. These mysteries are not failures of science, but its very engine. Every anomaly, every impossible measurement, every ghostly signal pushes our telescopes to see farther, our theories to stretch wider, and our imaginations to venture into realms we once thought were pure fantasy. They remind us that curiosity is our most powerful instrument, and that the universe always has another secret waiting just beyond the edge of our understanding. So the next time you look up at the night sky, remember that it is not a fixed tapestry. It is a living story filled with invisible hurricanes, diamond worlds, and runaway black holes. Astronomers are watching every single night, and the next great cosmic surprise could be announced tomorrow. Which of these 25 bizarre events captured your imagination the most? Let us know in the comments below, and if you enjoyed this deep dive into the mysteries of space, be sure to subscribe for more journeys to the edges of reality.